In this video, I'm going to describe the use of the ActionScript file class that points to individual files or directories within the local file system. For all of the demonstrations in this chapter, I'll be working from a project that's part of the exercise files. If you're following along with the exercises, go to the Flex Builder menu and select File, Import, Flex Project. Click the Browse button next to Archive File and select Chapter 04 Begin Project.zip. Notice that there's also a Chapter 04 End Project.zip that contains the completed source code for all of these demonstrations. Select the file and then click the Finish button to import the project. Next, go to the Flex Navigator view and open the project, and then open its source folder. You'll find a number of applications that are ready to use. Then locate the application directory aliases.mxml and double-click it to open it in the editor. If the application opens in Design View, click the Source button to look at it in Source View. And then I'll maximize my editor so I can see as much code as possible. This is a very simple beginning application that has a button which, when clicked, calls a function called testAliases. Place the cursor inside the function and you'll be ready to start coding. In order to represent a file or directory on disk, you create an instance of the ActionScript file class. As with all variables, you can name the variable anything you want. In this case, I'll declare a local variable to the function named f and data type it as a file. Notice that you don't need an import statement to address the file class. Now I'll instantiate the file class by calling the class's constructor method. When you create a new file object, you can pass in an initial path. The path is a string value which can point either to a particular file or directory on disk, or to a directory file that hasn't yet been created. For this first example, I'm going to pass in a simple string of file://. This is a special prefix that's used in AIR applications that addresses the root directory of the current volume. On Windows, for instance, if I'm working on the C drive, it would address the C drive root. On Mac, it would do the same. Now, to determine what the current file object is pointing to, I'm going to trace a property of the file object called native path. The native path property of the file object returns a string value. It's the location of the file or directory represented by this object, starting from the volume root. I'll save my changes, and now I'm going to debug the application. Notice in the background I can see the Flex Builder console. When I click the button, I'll create an instance of the file object pointing to file://, and then I'll trace the actual location from its native path. And you'll see that the native path value returns a simple \. If you're working on Mac, you should see a / instead. And that represents a basic difference between the two operating systems, that the Windows operating system uses backslashes to represent directories, while Mac and other Unix-based systems use a /. There are other string-based prefixes that you can use to address various key directories on the file system. For instance, two important directories are called the application directory and the application storage directory. There are other important directories called the desktop directory and the user directory. Each of these can be addressed in one of two ways, either through a string-based prefix or through a static property of the file class. I'll demonstrate the difference between the two using the application directory. I'm going to create another file object. This time I'm going to name it appdir, typecast it as a file, and once again I'm going to instantiate it using new file, and I'll put in a prefix of app:/. This is a reserved prefix in AIR, which means the directory in which the application executable is stored. This is a reserved string-based prefix, which references the application directory, that is, the directory in which the application executable is stored. Now I'll trace the results of that expression using the syntax appdir.nativepath. I can address exactly the same directory using a static property of the file class named application directory. I'll name this variable appdir2, once again data type it as a file, and this time I'll get a reference to that directory using file.application directory. Then I'll copy and paste the trace command. I'll change the second trace command to output the native path of appdir2. I'll save my changes, and debug again. I'll click the button to execute the function, and you'll see that the two coding approaches give you the same result. In either case, you've created a new file object which points to the location of the application, that is, where it's running from. In this case, it's the output folder of the FlexBuilder project, bin debug. There are three other special directories that you can address in this manner. The user home directory is a directory that's unique to each individual user on the local file system. The actual location of the user directory will differ depending on whether you're working on Mac, Windows Vista, or Windows XP. I'm working on Windows Vista in this demonstration, so I'll show you what it looks like when I run it on this system and then describe what happens on the others. I'll create another variable. This time it'll be named userdir. I'll set it as a file. And this time I'll get a reference using file.userDirectory. And then once again I'll trace the result, userdir.nativepath. I'll run the application in debug mode, click the button to test, and you'll see that the user directory on my system, Windows Vista, points to /users/David. In a very similar fashion on Mac, you would see a named directory under the users folder, while on Windows XP it would be under the Documents and Settings folder, and again the subdirectory would be named for the user name. There are other directories that you can address directly within the home directory of the user. I'll create two more and then trace them. The first will be for the desktop directory. This variable will address the desktop directory, that is, the directory that represents the visual desktop that you work with on either Windows or the Mac. I'll trace the native path of the desktop directory, and then I'll do something very similar for something called the docs directory. That is to say, the user's own documents area. And once again, I'll trace. I'll save and run the application in debug mode, test, and you'll see that I'm pointing now to the desktop directory and the documents directory under my user directory. There's one other critical directory that you work with. It's called the application storage directory. This directory is once again unique to each individual user, but it's designed to also be unique to the particular application. I'm going to create one more variable, and I'm going to call this storagedir, data type it as a file, and reference it from file.application storage directory, and then once again trace its actual location. I'll run the application in debug mode, test the application, and this time you'll see a much longer native path. I'll maximize the console so we can see the entire path. Once again, the actual location of this folder will differ, depending on whether you're working on Windows XP, Windows Vista, or Mac. Working on Windows Vista, the application storage directory shows up under an app data folder. On Windows Vista, the folder shows up under the user's home directory, under that an app data subfolder, under that a directory named roaming, and then a directory which is named for the application ID. Notice that the full application ID is used, in this case com.linda.airflex.chapter04, and then the name of the application directory aliases. And then finally under that directory, another directory named local store. The local store directory is always named the same, regardless of which operating system you're on. But the rest of the actual location of this directory will again differ from one operating system to another. So that's basically how you address the various directories. Once again, there are string-based prefixes that you can use instead of these static properties, but they give you the same result. They allow you to address these special directories that are either unique to the user or to the user and the application.